storm, there was heavy flooding. That was also captured by our flood map. You see there, where's Ayala, Makati Avenue. Yeah, ito ba Makati Avenue? Yeah. Yeah, that's Makati Avenue. You see that, yeah, it's captured. It was captured in our flood map. Next slide, please. All right. There's a star showing that place, that intersection. Next slide, please. Next slide. October 2, there was a thunderstorm. Okay, just press it twice. I was going home. I tagged it, and I looked at the map. Oh, there's flood. It's captured in our flood map. It's captured in our flood map. This one is in Banawe. Next slide, please. That one is Undoy. Next slide, please. But it's also captured. So October 2, those areas. Next slide, please. Okay, next slide, please. Okay. JRC, Jose Rizal University. So it's captured in our flood map. Next slide, please. We go on and on and on and on. All of those in that list of the MMDA flood-prone areas and every place that you will experience to flood are all captured in our flood maps. Next slide, please. But of course, we want to know what is the corresponding rainfall that would make a street flood such that we would know when that rainfall would cause an amount of flooding where cars will not be able to pass anymore. I think that's the ultimate question. When will it flood and will create heavy traffic? Okay, next slide, please. Next slide, please. Let's go on and on, on and on. They're all captured in the flood map. So we tried to make some simulations of different amounts of rainfall. 20 millimeters, 30 millimeters per hour, 40 millimeters per hour of rainfall, 50. And that part, next slide please, for example, in Quezon Avenue, corner Victoria Avenue, this is a digital elevation model, a representation of the landscape. You see the roads, and this is light detection and ranging. It's very, very high in resolution. Next slide please. So that's Victory Avenue, Quezon Avenue. This is somewhere...
Santo Domingo.
Yes, that's right. So if we have 20 millimeters of rain, we were able to capture that. You will have gutter deep or to ankle deep to gutter deep of floods along that road with just 20 millimeters of rain in 1 hour. Next slide, please. If it's 30 millimeters, that's torrential rain, you will have that amount of flooding that would happen there. If it's 40 millimeters of rain, next slide, please. That would be the scenario of the street in Victory Avenue. Next slide, please. And with 50 millimeters of rain, that's really very torrential rain. That's a large amount of rain falling for 1 hour. And that would be the corresponding flood. So what we're trying to do is to simulate, using the high-resolution topography and the rainfall, different types of rainfall, to be able to see the scenario that would happen for a particular intensity of rainfall that would be delivered within an hour. And we will do it, or we are doing it, for all of those places listed in the MMDA flood-prone list. So what would be the product? The product would be, since we have the sensors and we have the Doppler, or PAGASA has the Doppler, we can look at it and make some kind of forecast or prediction of the amount of rain. And even before it rains, because there's a prediction of the amount of rain, because we're seeing it from the Doppler, it's converted into intensity, we'll be able to say that this amount of rain that is expected to fall in a particular place would cause flooding traffic in a certain place of a certain height. That's what we are trying to do. But we haven't really done it yet completely because it's hard to do. But we can do it. I know we can do it, but it's hard to do. Next slide, please. Okay, and the reason why it's going down is because it floods is because of the landscape. No? Next slide, please. That's the landscape. It's really a depression, and that's why it floods. Next slide, please. Okay, next slide, please. All right. So what we try to do is, for example, we have a multi-hazard map, the landslide, the flood, the storm surge, all together. we can identify still safe places. I said that there's about 50%. 50%. So we can identify a lot of safe places. But if, for example, we've identified it already, and then there's a warning of government that there's probably a tsunami or a storm surge or heavy rainfall that will cause flooding, we just refer to the multi-hazard map. And then, from a particular type of location, for example, that point, we can calculate, next slide please. Okay, next slide please. All right, the road network. We have a road network that's available at Google, Waze as well. And then next slide please. We can calculate the travel time to go from this place to the safe evacuation sites. What I'm thinking of is probably you would like to know the travel time of your employees. No? How much time will it take for your employee to go from their house to the center? And we can easily calculate that using the road network. And we can easily calculate that if we know if there are blocks, if there are no blocks, if it's a free passage towards the places of interest. Those things we can do because we have the ability, we have the science, we have the technology, we have the maps, the high-resolution maps. We know what we're doing, and we can do it in terms of what is needed. But NOAA really is for disasters. But our work, the products that we can do, is only limited by our imagination. But it's really for disasters, and that is what we do. Thank you very much.
All right, to continue the ball rolling, another very promisingly informative session from an equally very capable speaker. He is the Senior Weather Specialist and Officer in Charge for the Climate Monitoring and Prediction Section of PAGASA. He's a BS Aeronautical Engineering graduate from PAT College of Aeronautics and has a Master's in Atmospheric Science from Ateneo de Manila University. Now I get the relationship between College of Aeronautics and Atmospheric Science. Okay. Must be very interesting being up there. And okay. All right. So, ladies and gentlemen, from PAGASA, Mr. Anthony Joseph Lucero.
Good afternoon. I will be presenting our products, and before I present our products, I will give you some analysis on the statistic of extreme weather that happened in the past years. So, okay, next slide please. This is my presentation outline, background information about PAGASA, climate of the Philippines, para medyo ma-familiarize kayo ng konti. And then extreme climate events, tropical cyclones, managing climate risk, and then we move on to climate outlook. So, let me tell you that I am a climate forecaster. Siguro ngayon lang nyo narinig yun, kasi yung pang-araw-araw nyo naririnig, weather forecaster po yun. Anything beyond 5 days is my job. Next slide, please. So this is PAGASA now. We have been modernizing, continually modernizing. We have lots of equipment. The government has been very generous to us. Pati yung salary namin and allowances, dinagdagan. Hindi na kami nahihirapan ngayon. Konti na lang. So, pakiclick ulit po. PAGASA shall be the authoritative voice in providing the warning for public safety. Pakiclick ulit po. So, next. Yan po. This is the background information. The Philippines is the third country most exposed and at risk to natural hazards. So, hindi na iba yan kasi sinabi nga ni Dr. Lagmay, 50% meron pa ring safe places in the Philippines. The other 50% is not safe. 50%, imagine. Average of 19 to 21 tropical cyclones a year. So, ang dami nating bagyo. I remember that whenever I attend a conference, international conference, my classmate would always ask me, Philippines, how did you manage to survive? You always have a tropical cyclone. And I always say that we manage to survive because we help each other. Sana naman, totoo yun. So that's tropical cyclone hazard. It has strong winds, excessive rainfall, floods will always be there, landslide, mud flows, tornadoes, storm surges. So sama-sama na yun. And then we also have a extreme climate event, El Nino, La Nina, droughts, and floods also. And then the monsoon, southwest and northeast monsoon. And then the intertropical convergence. So next. So bibilisan ko ito, mga 80 slides to eh. So this is the climate of the Philippines. Note that we only have two seasons, wet and dry, right? So, but it does not really say that there is a dry season over here on the eastern side of the Philippines. There is always rainfall all throughout the year on the eastern side of the Philippines. On the western side of the Philippines, we have two distinct seasons, wet and dry. Yes, okay? The other is wet and very wet. Next slide, please. So, yan po, climate type 1, type 2, type 3, and type 4. So, pakipindot po ulit. So, ito po, if we are to describe that in a graph, this is climate type 1, red. See that there isn't much rain over this month. And then on climate type 2, we always have rain. And then we have lots of rainfall during October, November, December. So, yan po yung sinasabi kong very, very wet. Next slide, please. If we have to sum up, this is the seasonal rainfall over the Philippines in southwest monsoon. Note that there are the bulk of the rainfall is over the western side of the Philippines during southwest monsoon, and that is April to September. And during the northeast monsoon, October to March, see the transfer of the extreme rainfall over the eastern side. And then we don't have much rainfall over the western side of the Philippines. Pero hindi nauubos yun. Meron pa rin yan. Okay? Unlike here, less than 2 millimeter per day. See? Walang red dito po sa eastern side. Next slide, please. So, the wind system during the habagat or the southwest monsoon, the wind is coming from the southwest because the air moves from the Indian Ocean going to mainland Asia. And then during the winter season of the northern hemisphere, wala tayong winter kasi we are in the tropics. Winter season of the northern hemisphere, the wind changes direction in the opposite. So northeast na yan, and then it goes to Australia. Next slide, please. So these are the weather system and associated hazard. We have thunderstorms, hindi ko na babasahin. Cold front, tail end, heavy rain yan, yung nagdadala na heavy rain. And then intertropical, low pressure, easterly, monsoon. Next slide. And then the weather-related hazard that cause disasters in the Philippines. These are recorded weather hazard that cause disasters in the Philippines, including, of course, Ginsaugon, Typhoon Sendong, Ondo, and so on and so forth. Next slide. So this is the landslide event. I just would like to show you the rainfall pattern during the landslide in Cherry Hills and in Payata. See that there is a consecutive days of heavy rainfall. Next slide, please. And then this is a photograph showing you flooding in Metro Manila during Ondoy. Next. So remember that Ondoy is not a very strong tropical cyclone. It dumps a lot of rainfall, causing floodings in Metro Manila. Next slide, please. So these are the recent tropical cyclone that devastated the Philippines. Ginsaugon, This is not a tropical cyclone. It is the cause of intertropical convergence zone. This is Typhoon Riming, Typhoon Milenio, and Typhoon Frank. Nakita lang natin yung barko na yan, but it really damaged sa Panay Island. Next slide, please. Okay, next. Extreme weather events, strategies after strategies. Kita natin from 2000. Most of that extreme climate events happen during the last 10 years. Next slide, please. So this is the statistic, one of the statistics taken from Office of Civil Defense. Tropical cyclone starts 1970 to 2012, affected people 154 million, casualties 26,000, damages to agriculture 231 billion, infrastructure 93 billion, private properties 13 billion. Total cost is 337 billion. Frequency, duration, and intensity of rainfall event have changed. Talagang napakapalad natin may project NOAA na tayo. More and more people are affected by hydromet-related hazard. Next slide. So this is a graph showing you the number of tropical cyclone from 1948 to 2013. The tropical cyclone is not increasing. It's actually decreasing. Very slightly. The number of tropical cyclone. Kita nyo yan? Kukunti na lang yan. So, but there is a notable damages brought about by tropical cyclone. So, next slide, please. And this is the statistic of tropical cyclone for each month of the year. This is the tropical cyclone season. See, June, it goes all the way to December. Next slide, please. So this is analysis of the extreme tropical cyclone, which has more than 150 kph wind. So what you are seeing is that there is a cycle. See that? And then this is 2013. But at 2014, as of this time, we only have 15 tropical cyclone. So it might be lower than what we are really expecting. So ito yung mga very strong tropical cyclone, intense tropical cyclone. Next slide, please. So this is a five-year frequency of tropical cyclone for Luzon, Southern Luzon, Visayas, Mindanao. Pag sinabi natin Southern Luzon, yan po yung Bicol region. So what we are seeing is that there are not much tropical cyclone in the last 5 to 15 years, but there is a increase in tropical cyclone over Mindanao. Next slide. So this is a map showing the frequency of tropical cyclone per decade in the Philippines. So what we are seeing is that during the early decades, there were more tropical cyclones that occurred in northern Luzon. If this trend persists, there will be more number of tropical cyclones in northern Luzon and Mindanao by 2011 to 2020. Next slide, please. And this is the annual total cost of damage due to destructive tropical cyclone in billions of pesos. So it's rising exponentially. The past 5 years showed the highest accumulated total cost of damage due to the occurrence of destructive tropical cyclone in the Philippines. As a matter of fact, the trend of the cost of damage is exponential, which has taken a considerable toll in the economic outlook of the country. Next. So this is another analysis on the trend of tropical cyclone. This column is the total damage for each tropical cyclone. 2009 is the Typhoon Pep.